Okay, folks, this is a trigonometric type problem, a trigonometry problem having to do with a Ferris wheel. It's a very common type of a problem. It illustrates a lot of issues relating to trigonometry. Sometimes it'll be in this format, other times it'll be in a format of the wheel turns at a certain rate for a certain amount of time. In this particular problem, they actually give us the angles that you rotated. So it's a little bit, it's a kind of a generic problem, but very, very useful, very common type problem. Okay, so here we are. Here's the problem. The seats of a Ferris wheel are 75 feet from the center of the wheel. When you get on the ride, your seat is 4 feet above the ground. Determine how far your seat is above the ground when, and then it gives you the two different scenarios. A is it rotates through an angle of 75% or 75 degrees, and B, it rotates through an angle of 3 pi over 2 radians. Okay, so let's take a look. First thing that we should always do, in my opinion, first thing we do is we write down the problem in this standard format that I like to use, which is you're given certain information, you're asked to find certain information, you have a little discussion about it, and then you actually have the solution. So that's the format I always follow. That way, even if I have no clue to life what I'm doing, at least I can get started on the problem and feel like I'm making some progress. Okay, so here we are. Here's what we're given. The seats of the Ferris wheel are 75 feet from the center of the wheel. When you first get on, the seat is 4 feet above the ground. Find how far the seat is above the ground when, and then it gives you the two scenarios. The wheel rotates through an angle of 75 degrees. Wheel rotates through 3 pi over 2 radians. So here's my discussion. First thing I always do is draw a cartoon. So here's my cartoon. It's not to scale. This is the Ferris wheel. The radius is 75 feet of the wheel. So 75 feet from the center to any one of these seats. Here's my seat, and the seat is 4 feet above the ground. So we have a circle of radius 75 feet. The problem does not specify if the rotation is clockwise or counterclockwise. As it turns out, I don't believe it makes any difference, but you get the idea. That's just something that's missing. Typically, in these kinds of problems, we always go counterclockwise. So that's what I'm going to do. Okay, now I observe that 3 pi over 2, that's 270 degrees, okay? Or another way of looking at it is it's 3/4 of a full revolution, okay? Because 2 pi is a full revolution. So 3 over 2 pi, that's 1/2 of a pi short of a revolution. If you added 1/2 pi to this, you'd have 4 over 2 pi. 4 over 2 is 2, so you'd have a full revolution. So you were short by 1/4 of a revolution, and we're going to use that here in a little bit. Okay, so now we go to the solution. All right, so what we have to do, again, cartoons are just so helpful. All right, sorry, I had a little technical difficulty there. So in any event, here's our cartoon, okay? So after you rotate 75 degrees, you will be 75 degrees from the starting point. Here's your starting point. You go up here 75 degrees. All right, do you see this cartoon? It's 75 feet from the center point right here, from this center point to the circle. That's the radius. In addition, when you started here, the seat was 4 feet above the ground. So that's 4 feet. So it's 75 plus 4. That's that distance. Okay. So now, after you go the 75 degrees, you're right here. So you're not at this point. You're at this point. So you're right here. Okay. So let's take a look at that triangle. Can we figure out what this distance right here is? Right there. Can we figure out what that is? Let's look at that triangle more carefully. It's the theta here is 75 degrees. This radius here is 75 feet. Now, it's just a coincidence that it's 75 feet and 75 degrees. The radius there is 75 feet. So the height here, this height right here of this triangle, oh, I'm sorry, I'm not to that point yet. So the height of the center, this center is 75 plus 4 is 79. Okay, and I made a mistake here and I didn't catch it. I apologize. It's 75 plus 4 is equal to 79. So correct that in your notes. The seat is a little bit below the center. It's a little tiny bit below there. Well, how much below the center? Let's look at the cartoon again. Here's our center. Here's our radius, otherwise known as the hypotenuse. This is a right triangle. Here's where our seat is. Okay, do you see how that's this cartoon right here? Obviously, nothing's to scale, right? Okay, this adjacent side here, that's the delta height. That's the height that we're interested in. Let's call it x. From our mnemonic of SOHCAHTOA, we know that the cosine of theta, this cosine of this theta here, is the adjacent, that's this guy, over the hypotenuse. That's x over the hypotenuse, or in other words, x over 75 feet. That 75 feet here, that radius is the hypotenuse. Okay, so theta is 75 degrees. So finally, if we just kind of work all this out, we solve for x, and boom, what do we get? We get 19.41, blah, blah, blah. Okay? So the height of the seat above the ground is going to be the 75 plus the 4. So that comes from here. That's the 75 plus the 4. That's 79. And then we subtract off that little delta, that little adjacent side. So that's 75 feet times cosine of 75 degrees. So you crank all that out, and what do you get? You get 59.58. So that's rounded off to the nearest whole foot. That's 60 feet above the ground. Okay, so now B is a very similar type of a problem, right? B is saying that you rotate 3 pi over 2 radians. Well, where's that cartoon? 3 pi over 2, you go around like this. Where do you end up? That's almost, that's 3/4 of a full revolution, okay? So you're right here. So now our theta is here. That's 90 degrees. That's our terminal equivalent angle. That's how much of a difference we are between the seat and from the original position of the seat to the ending position of the seat, okay? So now our relevant theta is 90 degrees, or pi over 2. Does our formula still work? Well, yeah, it still works. However, cosine of 90 degrees is 0. So our formula now becomes 75 plus 4, take away this part here. Well, that part here is 0. So 79 take away 0, or 79 feet above the ground, okay? Now, that's using the formula, but we can actually easily see this from the cartoon. The seat is at the same height as the center of the wheel. So there's two ways of looking at this, and obviously this helps us have some confidence that our answer is correct. Okay, so that's the end of this video.